Good morning, children. Today we are going to discuss multiplication of matrices. The product of two matrices A and B defined if the number of columns of matrix A is equal to the number of rows of matrix B. I am repeating, the product of the two matrices A and B defined if the number of column of matrix A is equal to the number of rows of matrix B. Let A is a matrix with the elements Aij, Bn a matrix of order m by n, and we have another matrix B of elements Bij, Bn n cross P matrix. Then the product of the matrices A and B is the matrix C of order m cross P. You can see here easily, matrix A has an order m cross n and the matrix B has an order n cross P. The number of columns of matrix A is equal to the number of rows in matrix B. Then only the product or multiplication is defined. And we'll have the resultant matrix C with an order m cross P. Now we look at the illustration. We have a matrix A with elements 1, minus 1, 2, 0, 3, 4. Another matrix B we have 2, 7, minus 1, 1, 5, minus 4. Here is the order of matrix A is 2 cross 3 and the B with an order 3 cross 2. That means matrix A has an order 2 cross 3. That means number of column is equal to 3. And a matrix B has an order 3 by 2. That means number of rows is 3. Hence, the number of columns of matrix A is equal to number of rows of matrix B. That means the product is defined. If the product is defined, then we have resultant matrix C of order 2 by 2 in this case. Now, we are going to look into the multiplication. How we'll do the multiplication of the matrices. Look boys here. Matrix A is 1, minus 1, 2, 0, 3, 4. And the matrix B is equals to 2, 7, minus 1, 1, 5, minus 4. When you multiply matrix A with the B, we have to symbolize like this way, the matrix A into matrix B. The resultant matrix of order 2 by 2 as I discussed and I told you earlier. So 2 by 2 matrix means we have A11, A12, A21, A22. So what elements will come over here and what process we follow to get at these elements we'll look into. To get the element at the place A11 in resultant matrix, we'll have to multiply R1 with C1. If we'll multiply R1 with the C1, we'll have the elements at A11. So how we'll get? We can check. So 1 into 2 plus minus 1 into minus 1 plus 2 into minus 5. Now, in order to get A12, we have to multiply row 1 with column 2. Row 1 with column 2 will get A12. How will go? 1 into 7 plus minus 1 into 1 plus 2 into minus 4. Now, we need to the element over here, that is A21. How will get A21? When R2 is goes and multiply with C1. R2 multiplied with C1. So we have 0 into 2 plus 3 into minus 1 plus 4 into 5. Now we need to get the element at the place of A22. How will get at the element at the A22? When you multiply row 2 with the column 2. When you multiply row 2 with column 2, we have 0 into 7 plus 3 into 1 plus 4 into minus 4. Now we'll simplify guys. When we'll simplify, we'll have the values over here 13, minus 2, 17 and minus 13. We can check it out. 2 plus 2, 4, 4 plus 2 plus 1, sorry, 2. 2 ones are 2 plus 1, 2 plus 1, 3, 3 plus 10 is 13. Now here 7 minus 1, 6, 6 minus 8 is minus 2. Now here 0, minus 3 plus 20, minus 3 plus 20 is 17. 0, 3 plus 3 minus 16, 3 minus 16 was what? Minus 13. So we have a matrix of order 2 by 2 as a resultant matrix C. The resultant matrix C we over here after multiplication. Right guys? Now I am recalling you all of you once again to how we'll obtain the elements of resultant matrix. To get A11 we have to multiply R1 with C1. To get the elements at A12 we multiply R1 with C2. To get the element at A21 we multiply R2 with C1. To get the elements at A22 multiply R2 with C2. Right guys? That's very simple to understand to get the resultant matrix. So this is called the multiplication of matrices. Right guys? Now as we see above, AB is defined. AB is defined. Then BA need not be defined. It is not necessary. And of course, in the above case, it is not. Where AB is defined, but BA is not defined. Why? We can understand with the help of definition. Right guys? AB and BA is defined only if A and B are square matrices of same order. Commutativity of multiplication of matrices is possible only if A and B are diagonal matrices of same order. And of course, diagonal matrices are the square matrices that we all of you know very well done. This is another note for you, all of you guys. So there are 4 notes I had given right now. AB is defined, but it doesn't mean that B is also defined. Means AB is defined, but BA is not defined. It may be, it may not be. But when it will define, we'll look into. AB and BA is defined only if A and B are the square matrices of same order. Commutativity of multiplication of matrices is possible if and only if A and B are diagonal matrices of same order, right? Means AB is equal to BA if and only if A and B are diagonal matrices of same order. Make it sure. Now guys, some properties of multiplication of matrices I'll discuss in next class. Thank you very much. God bless you.